Hello everyone, and welcome to VITA's first review video. In this video, we'll be covering Chapter 1 right triangles in all of the 8 lessons. In the description, I will link each individual lesson so you can jump quickly to them if you need, but let's get started. Okay, starting with the Pythagorean Theorem, our first question asks us to solve for x using the Pythagorean Theorem and most importantly, to give our answer as an exact value. Now, if the question tells us how to give our answer, we need to give it just like that because when you're taking standardized tests such as AP, IB, SAT, or ACT exams, you can get points taken off if you don't answer it the way they ask. Now, we know the Pythagorean theorem is a squared plus b squared equals c squared. C squared is always our hypotenuse, and A and B can be either of the two side lengths, it doesn't matter which. So let's plug in 7 squared plus 4 squared equals x squared. 49 plus 16 equals x squared. 65 equals x squared. Square root of 65 equals x. Now, because it wants exact value and 65 is not a perfect square, we will leave it as x equals the square root of 65. Alright, let's move on. Solve for x using Pythagorean theorem. Write your answer to 3 significant digits. So, 5 squared plus x squared is equal to 10 squared. 25 plus x squared is equal to 100. X squared is equal to 75. X is equal to the square root of 75. Now it wants us to give our answer to 3 significant digits. So plug that into your calculator, square root of 75, and you get x equals 8.6602. Now it's asking for 3 significant digits, so 1, 2, 3. And we get x is equal to 8.66 as our final answer. Alright, let's move on to special right triangles. Solve for the remaining values using your knowledge of special right triangles. Give your answers as exact values. So, what do we know about special right triangles? Well, this triangle given to us is a 45, 45, 90. We know that because it gives us the angles. So, let's quickly draw our own right triangle. And we know that the hypotenuse is equal to x times the square root of 2, and that the sides are both equal to x. Now, if we're looking for both of the two sides and we're given the hypotenuse, we can set x times the square root of 2 equal to 2. Right? So we divide both sides by square root of 2, and we get x is equal to the square root of 2. And now we just plug x in, and since a and b are both just equal to x, we get a equals square root of 2 and b equals square root of 2. Alright, question 2. Solve for the remaining values using your knowledge of special right triangles. Give your answers as exact values. Alright, well, this triangle we're not given the angle, so that's what we're looking for. But since we know it's a special right triangle, we know it either has to be a 30, 60, 90 or 45, 45, 90. And as we just saw in the prior problem, 45, 45, 90s have two sides that are the same length. And this triangle does not. So it must be a 30, 60, 90. Right, so now all we have to do is figure out which angle is 30 and which angle is 60. So if we draw our right triangle, we know that the angle that is adjacent to 30 degrees is equal to x times the square root of 3. We know that the hypotenuse is equal to 2 times x, and we know that the angle opposite of 30 degrees is equal to x, right? So now, like in the prior problem, we'll set 2x equal to 2 times the square root of 3, divide both sides by 2, x equals square root of 3. Right, so we know that the angle opposite 30 degrees should be equal to square root of 3. And square root of 3 is down here, which means A must be 30 degrees and B must be 60 degrees. Alright, let's move on to basic trigonometric functions. Find sine, tangent, and cosine of theta. Give exact values. Alright, so we know that sine of theta is equal to the opposite over the hypotenuse. We know cosine of theta is equal to the adjacent over the hypotenuse. We know tangent of theta is equal to the opposite over the adjacent. So if we take a look, the opposite is going to be 3 and the hypotenuse is 5. So we get sine of theta is equal to 3 over 5. The adjacent is 4, hypotenuse is 5. So cosine of theta is equal to 4 over 5. And the opposite is 3, adjacent is 4. So tangent of theta is equal to 3 over 4. And because it wants us to give exact values, we can just leave them all as fractions, but since these are pretty simple fractions, you could write them as decimals if you wanted to. Alright, question 2. Find cosecant, cotangent, and secant of both theta and alpha. Give exact values. So, you don't often see alpha unless you're working with two angles, but it is basically the same as theta, just a different way to denote an angle. So, we know that cosecant is the reciprocal of sine, so we would say that cosecant is equal to hypotenuse over opposite. We know that secant is the reciprocal of cosine, so that is going to be hypotenuse over adjacent. And we know that cotangent is the reciprocal of tangent, so that's going to be adjacent over opposite, right? So we know that, so now we just need to write those for both theta and for alpha. So we'll start with theta. Cosecant of theta is equal to the hypotenuse is square root 13, and the opposite is 2. Secant of theta is equal to square root of 13 over 3, and the cotangent of theta is equal to 3 over 2. Now we did the same thing for alpha. So cosecant of alpha is equal to square root of 13 over 2, over 3. the secant of alpha is square root 13 over 2, and the cotangent of alpha is 2 over 3. Alright. Solving right triangles. Solve for the missing values. Give answers to 3 significant digits. Alright. So, here we are given one angle and one side length. So the easiest thing is going to be to figure out the missing angle, right? Because we know that a right triangle, any triangle is composed of 180 degrees, and we know that angle A is 23 degrees, and we know we have a right angle. So we can say 180 minus 90 minus 23 will give us angle B. So 180 minus 90 minus 23 is equal to 67 degrees. Right? So we can say that B is equal to 67 degrees. Right? So now that we have all 3 angles, we can solve for the side lengths. Right? And all we need to do is find one side length, and then we can use Pythagorean Theorem to find the missing one. So, let's say that the tangent of 23 degrees is equal to A over 7, right? Because that's our opposite and our adjacent. So then we multiply both sides by 7, so that we're solving for A. We get 7 times tangent of 23 is equal to A. We can go ahead and plug that into our calculators, and just make sure that your calculator is set to degrees rather than radians, because you'll get a different answer when you're using our trig functions if you're not set to the correct mode. 7 times tangent of 23 degrees is equal to 2.9713 equals A. It wants 3 significant figures, so we'll say that A is equal to 2.91. Now, it's important to remember that while we're doing most of our calculations, we need to use the value that we got in our calculator rather than our rounded version. Otherwise, our answer for the third side length won't be correct. So, we're finding our hypotenuse, which is c squared. So we can say that 7 squared plus 2.913 squared is equal to c squared. 49 plus 8.828 equals c squared. 57.828 is equal to c squared, square root of 57.828 equals c, and we get c is equal to 7.604. So 3 significant digits, so c is equal to 7.60. Alright, let's move on to question 2. Solve for all missing values. Give values to 3 significant digits. Alright, so we're given 2 side lengths and no angles. So the first thing we can do is go ahead and solve for our missing side length using Pythagorean Theorem. So we need 2 squared plus a squared is going to equal square root of 14 squared. So 4 plus a squared equals 14. A squared equals 10. A equals the square root of 10. Right? So we need 3 significant digits, so square root of 10 is equal to 3.162. So we'll say that A equals 3.116. Okay. So now we need to find the 3 missing angles. So to do that, we'll say that the sine of angle B is equal to 2 over the square root of 14. Now we need to solve for B. So the way we would do that is we would need to divide by sine, right? And I know we haven't gone over this. We'll go over this in a later chapter. But I'm just going to quickly explain to you what you would plug into your calculator to do that. So you would say that B is equal to sine to the negative first, right? Because when we do anything to the negative first power, it becomes 1 over that number, right? So what we're doing is instead of dividing by sine, we're going to multiply by the sine to the negative first power. So write sine to the negative first times 2 over square root of 14. So that's one way you can plug it into your calculator. Some calculators will instead have a button that says arc sine, and that is the same thing as sine to the negative first. Okay, so there's no difference, but just plug this into your calculator of 2 over the square root of 14, and you will get, or you should get, B equals 32.311. Okay, so we'll use significant digits. Oops, 32.3 degrees. Alright, and now all that's left to do is to solve for the final angle, right? And so we have 2 angles, right? We have the 90-degree angle and the angle we just solved for. And so we can do 180 minus 90 minus 32.311. Remember to use that full value. And we get 57.688 degrees and 3 significant digits. So we get A is equal to 57.7 degrees. Alright, and we've reached the halfway point. So now we are going to move on to measuring rotation. Give the measure of this angle is both a positive and negative value, and of course, conveniently, our angle is not there, so let me quickly draw an angle for us. Alright, so give the measure of this angle as both a positive and negative value. Okay, so to do that, right, positive values are going to go counterclockwise, and negative values are going to go clockwise. Okay, so we know that each quadrant is 90 degrees. We have 90 degrees here. And as we just saw while I did the ruler, this is a 45-degree angle. 45. So we go 90 plus 45 equals 135. So we know that the positive value is 135 degrees. Now for the negative value, I'm going to add 90 from this quadrant, 90 from this quadrant, and 45 from this. So 90 plus 90 plus 35 equals 215. So our second angle, remember it's going to be negative because we went clockwise, is going to be negative 215 degrees. Give the coterminal angles for the angles shown below. Right, so here we are given the measurement for the angle is 210 degrees. And to find a coterminal angle, we either find the negative value of this angle, or we can add 360 to the angle. So we will do both. So we'll add 90 for this quadrant, and then we need to figure out how much to add here. Well, we know this is 90, this is 90, so what must this be? So 210 minus 180 equals 30, and so if this is 30, and this entire part is 90, we know this must be 60. So we can say 90 plus 60 equals 150. It's going to be a negative. So in a one coterminal angle, it's 150 degrees. Now, to find our second coterminal angle, we will add 360 degrees to the angle we're given. So 210 plus 360, we get 570 degrees. Alright, moving on to applying trig functions to angles of rotation. For the 6 trigonometric functions where 4, negative 6 is a point on the terminal angle theta. And I have written alpha here instead of theta, so let me fix that real quick. There. Okay. So, we know that this point right here is 4, negative 6. Right? So we know the components of this angle, that it is 4 units in the horizontal axis. So we know that this line right here, if we were to connect it to make a triangle, would be 4. And we know that this line right here would be negative 6, the y component. Right? So we have the first two sides of our triangle. And all we would need would be our third for us to write our trigonometric functions. So we'll plug it into Pythagorean Theorem. 4 squared plus negative 6 squared is equal to x squared. 16 plus 36 is equal to x squared. 52 is equal to x squared. Square root of 52 is equal to x. So we need to start thinking the square root of 52. Now all we need to do is find our trig functions, all 6 of them. So we know that sine of theta is going to be opposite over hypotenuse. So negative 6. Oops, sorry, not negative 6. 4 over square root 52, right? But we can't have a radical in the denominator, so I wrote 25. So we have to rationalize, so we're going to multiply both the numerator and denominator by square root 52. So we're going to get 4 times the square root of 52 over 52. Cosine of theta is going to be negative 6 over square root 52. We have to rationalize, so we'll do the same thing, and we get negative 6 times the square root of 52 over 52. Tangent of theta is equal to 4 over 6, negative 6. And we don't have to rationalize. We have cosecant, which will be equal to square root 52 over 4. And we don't need to rationalize because the radical is in the numerator. Secant of theta is equal to square root 52 over negative 6. And cotangent of theta is equal to negative 6 over 4. Question 2. The point 3, 7 is the point on the terminal side of angle alpha. Find the radius of the circle. Okay. So we know that this point right here is 3, 7. So we know the x component is equal to 3, right? We know the y component is equal to 7. And we are looking for the radius of the circle. So the radius is any point on the circle that is connected to the center point. And we see that right here, right? Our hypotenuse of our triangle happens to also be the radius. So all we need to do is find the radius of the circle using Pythagorean Theorem. 7 squared plus 3 squared equals c squared. 49 plus 9 c squared. We get 58 equals c squared. Square root of 58 equals c. Alright. C equals square root of 58. Okay. Let's move on to trig functions of any angle. Find the sine, tangent, cosine of angles alpha and theta. So, let's start with angle alpha. Sine of angle alpha is going to be 7 over square root 65. But we have to rationalize, so it's going to be 7 times the square root 65 over 65. Tangent alpha is going to be 4 over square root 65. We rationalize and get 4 times the square root of 65 over 65. Then cosine. I just wrote, my apologies. This should actually be cosine. I said tangent. Now we do tangent of alpha, and we get 7/4. Now we do theta. Sine of theta is equal to 4/65, which is equal to square root of 65 times 4. Over 65. Cosine of theta is equal to 7/65, which is equal to 7 times the square root of 65/65. And lastly, tangent of theta is equal to 4/7. Okay, find the trig functions for angle alpha. First, we need to find the rest of the missing side lengths. So, let's go ahead and do that. We'll say that sine of 22 degrees is equal to x over the square root of 5. Square root of 5 times sine of 22 is equal to x. And let's see, square root of 5 times sine of 22 is x equals 0.8376. So now we know that this is 0.8376. And we can use Pythagorean Theorem to find our missing side length. So 0.8376 plus x squared equals square root of 5 squared. 0.7016 plus x squared equals 5. X squared equals, let's see, x squared equals 4.298. X equals the square root of 4.298. X equals 2.073. Alright, now we need to find our trig functions. Okay, so finding trig functions of alpha. Sine of alpha is equal to I'm just going to write it to 3 sig figs because we're not actually, getting an exact value. So I'm just going to write it for simplicity. 2.70 over square root 5. Rationalize 2.70 times square root 5 over 5. Cosine of alpha is equal to 0.838 over square root 5. We rationalize 0.838 times square root 5 over 5. Tangent of alpha equals 2.70 over 0.838. Okay, those are the first half. here. Then cosecant of alpha is equal to 0.838 over square root 5, which is 0.838 square root 5 over 5. Secant of alpha is equal to 2.70 over square root 5, which becomes 2.70 square root 5 over 5. And cotangent alpha is equal to 0.838 over 2.70. Alright, moving on to what I believe is our last section, relating trig functions. Find cosecant of alpha given sine of alpha is 0.9. So as we've talked about, sine is equal to opposite over hypotenuse, whereas cosecant is equal to hypotenuse over opposite, the reciprocals of each other. So all we have to do is find the reciprocal of 0.9. Now we can write 0.9 as 0.9 over 1, and so it's easy to tell that the reciprocal would be 1 over 0.9. So 1 divided by 0.9 is equal to 1.1 repeating. So we would say that cosecant of theta is equal to 1.111, right notation. Now tangent, cotangent, right? Tangent is equal to opposite over adjacent. Cotangent is equal to adjacent over opposite. The reciprocals of each other. So 1.2 over 1 becomes 1 over 1.2. And we get that cotangent of alpha is equal to 0.833 repeating. And that is all. Thank you for tuning in to VITA's review video. Please either fill out our Google form that is linked in our account description, or drop a comment on this video and tell us how we can improve. Thank you.